Okay, so we're going to start today in our table of contents, and we are going to add page 2, which is metric prefixes. So metric prefixes and conversions. Okay, and then I'm going to turn over to that page. You guys probably remember doing notebooking when you were in middle school. But be sure and number our page, title our page, the same thing that we did in our table of contents. Alright, so you guys said that you remember doing metric prefixes in the SI system before, but let's put some labels on words that we need to know. So we have SI base units. SI base units are measurable just with instruments that we have. We don't have to do any math to get them. And they are the standard units used in formulas. So they are the standard units used in formulas. Oops. So that is critical. As we move forward and we start to do formulas, we start to think about particularly gas laws, you have to use these units in order to cancel them out when you're doing unit analysis. So it's really important that we memorize the standard units so that we know what to use when we come to a formula. So the things that we measure length, we measure time, we measure mass. There's something else that we measure. You guys, last year we asked you to take your temperature every single day, right? So temperature is something that we measure a lot of times. We measure amounts of things like count. Oops, you can't see that. Count or amount. Okay. And then there's some things that we won't measure in this class, but you need to know what the base unit is. Okay? So some of those things are electric current. When you go to physics, you'll kind of be expected to know the units for electric current. And we'll talk about the units here in the next column. But then you tell me what this one is. You will not measure this in this class at all, but you will measure it when you go to other classes like AP Chem or those things. Luminous intensity. What does that word really mean? It's light, because luminous means light up. And intensity, it's hard to define intensity without saying how intense it is, but how strong it is. So we could call it brightness. This is a pretty standard list of things that you need to know the base unit for. So, length, the base unit is the meter. That's what's used in all formulas. The abbreviation for meter is little m. Okay. Time, what do you think we measure time in? What's the base unit for time? I heard somebody whisper seconds, that's right. And abbreviation is little s. And then temperature. Temperature might throw... Wait, we didn't do temperature. Mass. Wrong order. What do you think we measure mass in? I didn't hear anybody whisper it, but mass is sort of the exception to the rule. The standard unit for mass is a kilogram. So it is kg. I kind of want to make a big deal about this one because this is the only one that has a prefix. So I am going to highlight it with a big red box. I'm going to give you a hint right now. Later on in your final and later on in different questions, you will be asked what is the only base unit that has a prefix? Or you'll be asked to pick out the base unit for mass. And given in the answer is gram and kilogram, both one of the multiple choice. Mass is the only one with a prefix. It's the only one with a prefix. So make sure that you kind of commit that to memory, that mass, kilogram, the only base unit with a prefix. So that's the one we're looking for with the formulas that we use. Temperature is also one that might throw us off. We measure temperature in degrees Celsius or degrees Fahrenheit, but the base unit is Kelvin. There is no device in this whole building that can measure Kelvin. So every time that you do a problem with temperature, you're probably going to have to do a conversion. Okay, every time you do a problem with temperature, you'll probably have to do a conversion, and we'll go over those temperature conversions later on. All right. I don't want to go too fast, and then amount. Like, we have words for amounts, like a dozen or a gross. A dozen is 12, a gross is 144. Well, this amount is thinking in chemistry terms, thinking about atoms or molecules. And it's a mole. A mole is 6.022 times 10 to the 23rd. So its abbreviation is a little bit silly. It's 3 letters and the word is only 4 letters long. But such is science. So this mole is a count. It is an amount of things. And that's going to be a whole unit that we spend an entire unit on. So we will get very familiar with the mole. Electric current is measured in amperes. And that is a big A. Luminous intensity is the candela. It's abbreviated CD. So that one is a little bit, you can think of candle when we think of brightness. Okay. Like I said, though, the ones that we will really use are these top 5. The last 2 we probably won't use in this class at all, but you still need to know them. Alright, so if these are base units, this is what we use in all the formulas. We also have derived units. So, derived. What does the word derived mean? What do you think? If I derive a conclusion, what am I doing? Finding it, okay, that's a good way to start. Derived units are units that are come up with using math. So if we derive a conclusion, we're using evidence to come up with that conclusion. But a derived unit, we use math to come up with the conclusion, with the unit. Okay, so derived units. So what on earth does that mean? Use math. Here's an example. Area. How do you come up with area? Length times width, right? And so when we know length and width are both distances, they're both length, they're both lengths. We know that we're going to have meters, but if I multiply meter times meter, I'm going to get square meter. And so we abbreviate that like this. What's another one that you have to use math like that? I heard somebody whisper volume. So volume, length times width times height. So what unit do you think we'll have? Does somebody mumble cubic meter? Okay. And there's just a couple more that are pretty commonly used. There's a lot that you could call a derived unit. Speed. How do I come up with speed? Some of you are getting ready to think about driving or that speed limit. Think about that. Miles per hour, so miles is a distance, right? Per means divide, hour is a time. So distance divided by time. Now, we use miles per hour because we live in America. But when we come back to our base units, miles is a length, and time, our derived unit, is going to be meters per second. So let's make note of that. Okay. Another one that you've used lots and lots of times is mass. I don't know why I'm using two lines, but we'll do it. Mass density. How do you find density? Do you remember that from lots of science classes before? Mass divided by volume. So again, if this is the math that we're going to use to come up with it, what is the base unit for mass? Somebody whispered kilogram. Practice that one. That one will come up on questions later. Kilogram per, because we're dividing. What's the unit for volume? Cubic meter, so kilogram per cubic meter. Okay. A lot of times, and especially classes that you've already taken or that you'll take here in the next little while, we're not going to measure in meters to find the density. We'll measure in centimeters or millimeters, like the volume of a liquid we might use. So again, we'll have to do a conversion there. So it's important. All right. Go ahead and pull out that paper that I gave you just a little bit ago. And I'm going to pull my camera up so that we can see the whole picture. And let's kind of digest it together. Okay. Some of this paper we won't use very much. Okay, some of it is just extra information. Like this column here. We probably won't use this column at all. But this column is the column that you would use if you were trying to use scientific notation. So if I have 1 petameter, then I would have 1 times 10 to the 15 meters. Okay? So notice how that base unit, so let's mark that. I'll just go ahead where it says none. I want you to write base. Which measurement will that word base not work for? Which one is the only one with the prefix already? Mass, right? Because mass, the kilogram is right here. It already has a prefix. So we want to be mindful of that at all times whenever we're thinking about these kind of problems. All right, so then we have the actual prefix name. So this is what we say. And then this is the symbol that we would write in front of the unit. Okay. The year that, we don't really care about the year that it was started since the year that we've used it, but I do want you to notice something here. Notice this 1795. Which units does that go with? We're gonna just take a moment to think about it. These 6 are the units that you have already, we'll get closer so you can see it. These 6 are the units that you have already been using. You know kilo, you know centi and milli. Might not remember deca, hecto, but these are the 6 that are closest to the base. So we didn't have to zoom in too far, we didn't have to zoom out too far to be able to see this or to be able to measure this, right? Notice that, because the next step, 1960, that correlates with jumps in technology, okay? In 1975, 1991, having to do with the telescopes, okay? So that's just a sidebar rabbit trail we could go on, but and then you can see the word and the multiplier that you need for that. Let's not waste any more time, and we'll write down our steps to do this, right? Because you are going to have to be converting between units, not just from a prefix to the base. So I'm going to write my steps right here, and I do not know why my camera is coming out of focus today. So the first step when we're doing a conversion is we're going to find the prefix we have. Okay, we'll go through examples after we write the steps. We have 6 steps basically. Find the prefix you need. Number 3, count the steps between. Number 4. This one you're probably going to have to see in action, but it makes a lot of sense. You're going to put a 1 and the number of zeros that you had steps. So that is going to be what you either multiply or divide by. I'll show you that example here in a second. But for instance, if I'm going from mega to peta, let's say, there's 1, 2, 3 steps in between. 1, 2, 3 steps in between. So I would put a 1 with 3 zeros behind it. We'll see that in our examples. And then number 5 is the most critical step, and also one of the steps you could probably do in your head. But number 5 is decide which operation to do. Decide which operation to do. Alright. Am I talking about surgery here? No, I'm talking about multiply or divide. Okay, so steps, if your steps go down, multiply. If your steps go up, what are you going to do? Divide. Okay. Then you're going to calculate. So 6 is sort of one you could also do in your head, but calculate. Alright. So let's do an example. Let's do an example. If we have, let's say, 800 nanometers. Let's try to see where you can get into this a little bit. Yep. Example 1. We're going to go 800 nanometers to decimeters. Right. So my first step said find the prefix you have. So I have a number that has nanometers. So I'm going to go, all right there's nanometers. Okay. And I want to get to decimeters. Right there's decimeters. All right. So the next step says count the steps between. There's 1, 2, 3, 4 steps. Alright. And then next step, number 4 says put a 1 and the number of zeros you had steps. So I had 4 steps. I'm going to say 1, 2, 3, 4. Alright. So I've got my number, 800 nanometers. And I've got my steps. I have 4 steps. Now I need to decide, my steps go up. I'm going to decide the operation to do. So if my steps go up, right here, I'm going to divide. Okay. So then my answer is what? How did you do that? Oh, calculator. I was going to say, did you? Because a lot of people, once you get to this point, they'll just move the decimal place one or the other. And to be honest with you, I'm going to share right now. I inevitably don't move it the right number, so I just plug it into my calculator too. Because if I just plug it into the calculator, I'm never going to get it wrong. But if I trust my brain, there's a good chance I might make a mistake, okay? I'm honestly pretty clumsy, so we need to do what works for us and plug it into the calculator. Thank you. That made me feel better about life. All right, so nanometers. So now I know I have 0.08 decimeters. Okay. That's a lot of steps, but if you follow the steps, you will never get it wrong. And once you follow them so many times, you'll probably be pretty good at them. Give me a thumbs up if you want to see one more example. I see no thumbs except ones. Only one thumb? Alright. Well, I tell you what, I will do a couple examples here in a second, but if most of you feel like you don't need any examples, then I'm going to give you a couple other instructions. Okay? For our class, you are going to have to memorize part of this table. Okay? Chances are you already have these in this box here memorized. I would like to see you memorize all the way from tera down to pico. Okay, so we're going to add 3 on both sides. Alright? You need to memorize tera, giga, mega, kilo, hecto, deca, unit, deci, centi, milli, micro, nano, pico. Okay? I would like you to memorize these steps that they take as well. So let me point out one thing, and I'll do an example of this before I move on. I want you to notice deca is 10 to the first, hecto is 10 to the second, kilo is 10 to the third, but mega is 10 to the sixth. What happened to 4 and 5? There's just not a name for 4 and 5, okay? So what you need to remember is don't forget steps 4 and 5, okay? So let's do an example of going from hecto, well, we'll go from giga to hecto, okay? That way we can do an example of going down. So, let me get my other pen. Example 2. I have 50, well, I wrote a 7. If I have 7,200 giga meters, and I want to go to hectometers, what do I need to do? My first, find the prefix I have, so here's giga. Alright, and you cannot see what I'm doing. And I'm going to find the prefix I need. Here's hecto. Yeah, I did. Okay. And then count the steps in between. Well, I go from 9 down to 2. So how many steps are between 9 and 2? 7. Okay, so if you just count those lines, you're going to mess up. Because we got to remember there's an 8 and a 7 in there, and there's a 4 and a 5 in there. So 9 minus 2 is 7 steps. So I am going to have a 1 with 7 zeros. I know, that's excessive, but I wanted to point it out. I have my original number, 7,200. Okay. Then my next step. If my steps go down, I'm going to multiply. Well, in this case, they go down. So I am multiplying. And I'm going to get a ridiculous big number, but that's okay. 72 and 7 zeros. Okay. So just don't forget that the steps are really the numbers that we have on the exponents here. Alright, so I'm going to quit recording that.